Okay, hi everybody. This is a longer video that I'm going to make that goes through how to solve each of the types of problems on that mole practice problems homework that you have to turn in completed and as accurate as possible on Tuesday. So for our first problem, number 1, where it says atomic mass versus molar mass, I'm going to show you how to solve the second row there where it says Fe2O3, because I think if you can solve that one, you'll be able to work backwards to the other problems. So the compound that we're dealing with is Fe2O3. So what that means is that we have 3 Fe's. We have 3 of those. Or sorry, 2 of those, my bad. We have 2 of those, and we have 3 oxygens. So remember that these subscript numbers right here refer to whatever element they come right after, and if there's no number after an element, that means there's only one of it. So the first, that's the first box. This is what should go in. This is what should go in that first column there, where your problem says list the atom types and numbers of each type of atom. That's what should go in that box. The next one, where it says atomic mass. In order to find that out, we need to figure out what the atomic mass of each individual element is. So if you look at a periodic table and you find Fe, which is iron, on the periodic table, it is in the middle section. It's like the 4th row down right in the middle. It's atomic number 26, and its atomic mass is 55.9. So we're going to write 55.9, it's a decimal. And we have 2 of those. So we're going to multiply it by 2. And we're going to add to that 3 times the atomic mass of oxygen. Now the atomic mass of oxygen, its atomic number 8. Its atomic mass is 16.0. 16.0. And so what we're basically doing here is we're doing Fe plus Fe plus O plus O plus O. So we're adding together all of the elements that are in that compound. And so we're just going to put that into a calculator. It's 55.9 times 2, and add to that in parentheses 3 times 16. Make sure you use parentheses, even though most calculators should know that 3 times 16 gets done before it gets added to that previous number. Make sure you're putting things in parentheses just to be safe. So your answer is going to be 159.8, and your units are AMU for that middle column there, because if we're talking about atomic mass, that's measured in atomic mass units. Sorry, it's supposed to be a decimal. I'm just having a hard time drawing good decimals here. For the next column over, that far right-hand column where it says molar mass with correct units, the number is the same. So for molar mass, the number stays the same as atomic mass, but now it's 159.8 grams per mole. So this right here is the atomic mass. This down here is the molar mass. And if we wanted to turn that molar mass into a conversion factor to use in a dimensional analysis problem, it means 1 mole of Fe2O3 is equal to 159.8 grams of Fe2O3. That's what a molar mass is. It's how many grams are in 1 mole of that substance. Okay, so now we're going to move on into those conceptual understanding questions. These ones I'm just going to talk through. So how is the mole similar to a dozen? That we've talked about a lot in class. So we know that a dozen is 12 of something, and that a mole is 6.02 times 10 to the 23 of something. So they're similar in that they're both units used for counting things. Which contains more atoms, a mole of copper or a mole of gold? That's number 3. Think about what a mole means. What does, like, in order to have a mole of copper atoms and a mole of gold atoms, how many would you have of each? It's almost a trick question because it's the same, right? Just like a dozen cookies is the same number as a dozen chickens, even though that's obviously not the same. You wouldn't use them the same way. They don't weigh the same. But a dozen is still the same number as a dozen of anything else. So the same thing goes for a mole. A mole of something is the same number of that thing as a mole of anything else. Now number 4, which weighs more, a mole of copper or a mole of gold? For that, you have to look at the periodic table. So copper is Cu, atomic number 29, and its molar mass is 63.5 grams per mole. So copper equals 63.5 grams per mole. And gold is Au, it's number 79, and gold is 197.0 grams per mole. So Au equals 197.0 grams per mole. So that's the mass of this is the mass of 1 mole of copper, and this is the mass of 1 mole of gold. So you can use those numbers to figure out how many or which one, a mole of which one would weigh more. So looking at number 5a, says how are the terms molar mass and atomic mass different from each other? I'm going to let you think that one through, but just remember what I talked about before when I was filling in that chart up above, and same goes for B, how are the terms the same? For number 6, you have this sort of thing where it has grams. I'm just going to abbreviate on the far left, an arrow, moles, again I'm abbreviating, and then atoms and molecules. Oops. Okay, whatever. Atoms and molecules. And so on this left-hand arrow between grams and moles, you should write molar mass. Because in order to convert between grams and moles, you need to use a molar mass. So whether you're going from grams to moles or from moles to grams, you're gonna need molar mass to do that. Now on this other arrow on the right hand side, you should write Avogadro's number. So it's Avogadro'' number. And that's 6.022 times 10 to the 23. That's what we're going to use when we're converting from moles of something to atoms and molecules of something, or vice versa, from atoms and molecules to moles. Because remember, that number is a counting unit. That's how many of something we have. Okay, moving on now to number 7. I already have written my given on the left-hand side, because the question is, given 12 grams of aluminum, how many moles do you have? So I'm going to multiply by something, and I know that I want to have my units, which are grams of aluminum, over here on the bottom. So I'm going to put grams of aluminum down here. And I know that to get from grams to moles, I need to use a molar mass. And by looking at a periodic table, I can find aluminum, which is atomic number 13. Its atomic mass is 27.0. So, or 27.0 AMU. So its molar mass is 27.0 grams per mole, or 27.0 grams of Al is equal to 1 mole of Al. So these are the same things, both this and this are the same thing, but this is the molar mass and this down here is the conversion factor. So if this conversion factor, I just crossed it off a little bit, if this is what I'm going to use in my equation, and I know that grams of aluminum is down here on the bottom, I need to take from the side where it has grams of aluminum, which is right here, and I'm going to use that same number, 27.0, to set up my equation. On the top is going to be whatever it's equal to, which is 1 mole of aluminum, so that's going up here, 1 mole of Al. And I can cross off grams of aluminum because I have it on both the top and the bottom. Now, at this point, I have my equation set up so that the only units left over are the ones that my question asked for, which is, trying to change color here, but it's not letting me, moles of aluminum. And so that means that I'm ready to solve. So in order to do this, I would do 12 times 1 over 1 times 27.0, which is just the same as 12 divided by 27. And whatever my answer is, my units, which would be whatever I have left over, is going to be moles of aluminum. So I'll let you do the math on your own, but 12 divided by 27 moles of aluminum is going to be my final answer there. Okay, moving down to question number 8. It says how many atoms are in 2.00 moles of Li. So if I write my given, oh, I gotta have a brush in order to do that. If I write 2.00 moles of Li over 1, it's going to be multiplied by something. And I know that on the bottom of my next fraction, I need to have moles of Li because I'm going to try to cancel that out. So moles of Li goes down here. Now, because I'm going from moles to, to atoms or molecules, in this case it's atoms, I know that I need to use Avogadro's number. So Avogadro's number tells me that 1 mole of anything, in this case it's going to be Li, is equal to 6.022 times 10 to the 23 of that thing, so atoms of Li. Remember, it's just a counting unit, so just like you could have a dozen atoms of Li or a dozen soda cans or a dozen televisions, you could have 6.022 times 10 to the 23 of those things, and it would be a mole of those things, even though technically you couldn't have that many soda cans because we know that would cover the whole Earth to 8 miles. But anyway, so I know I have moles of Li here, so I want to use the side of the equation where I have moles of Li. So the number that goes with that is going to be 1. So 1 mole of Li goes on the bottom. And 6.022 times 10 to the 23 atoms of Li goes on the top. And so moles of Li crosses off here and there. And now we have the units left that our question asked for, so we're ready to just do the math. So it's just going to be 2 times 6, or 2.00 times 6.022 times 10 to the 23. Whatever that gives us, our units are going to be atoms of Li, and we're going to answer with 3 significant figures because we have 1, 2, 3 significant figures in our given. Okay, looking down at number 9 now, this is the most complicated type of question we've had so far. And it says, how many atoms are in 55 grams of iron? So 55 grams of iron, or 55 grams Fe, is my given, and I wrote that on the left-hand side of my page. I also wrote this down here because these are like the conversion factors that I'm going to use to get between things, and I wanted to make sure that I had those available to me. So I start with grams, and I start with grams, which is here, and I'm trying to get to atoms, which is over here. In order to do that, I have to go through moles. I can't go directly from grams to number of atoms. So I'm going to multiply by, and now I need to find my molar mass of iron, which is on the periodic table. Iron is atomic number 26. Its molar mass is 55.9, or 55.8, sorry, 55.8 grams per mole. So that means that 1 mole of Fe equals 55.8 grams. So grams of Fe is going to come on the bottom, and I'm going to put 55.8 as the number that goes with that. On the top, I'm going to have 1 mole of Fe because that's what it's equal to, and grams of Fe crosses off there and there. Now, I'm not done yet because what I have now are moles of iron, and I need to get to atoms of iron. So I'm going to take my units, moles of Fe, and bring them down to the bottom here, moles Fe. And I see over here with my conversion factors that to get from moles to atoms, I need to use Avogadro's number. So that means that 1 mole of Fe is equal to 6.022 times 10 to the 23 atoms of Fe. So moles of Fe is down here. Moles of Fe and my conversion factor is right here. So I need a 1 there. And on top is going to be 6.022 times 10 to the 23 atoms Fe. Moles of Fe crosses off here and here. And now we're just left to do the math. So it's 55 times 6.022 times 10 to the 23 in parentheses. Multiply that and then divide whatever number you get by 55.8. Your units are going to be atoms of Fe because that's all that you have left over, and that's what your problem asked for. And that is how you solve those type of problems. If you're still feeling confused after this video, you really, really need to make the time to stay after school on Tuesday because this will be on the test that we have coming up on Thursday. See you guys on Tuesday. Bye!